This class is for class 9th, and chapter we are doing is Coordinate Geometry, chapter 19, and the book we are following is Understanding ICSE Mathematics by M.L. Agrawal. Now in this class, in the previous class, we have already done exercise 19.2 and we have done up to question number 3. 1-2 questions more I will be discussing, and then we will be moving on to the next topic. So the next question that I am taking is question number 5. They say draw a graph of equation y is equal to 3x minus 4. First of all, you have to draw the graph of this equation, and then you have to find the value of y when x is equal to minus 1, and you have to find out the value of x when y is equal to 5. These two values you have to find with the help of the graph. What we are going to do, we have to solve this equation with the help of the graph. So first of all, what we do, you can see that first of all we convert the subject, we make the subject as y. It is already there, so no need to change. Simply we will make a table, and in the table we take at least 3 values. So x and y. Now when we put x as 0 in this equation, y will become minus 4. If we take x as 1 in this equation, y will become minus 1. And if we take 2 in this equation, 3 to the 6 minus 4, that is 2. So we have got the 3 points. I am naming them as A, B and C. Now I will be drawing the graph. This is x-axis, x, O, x dash. This is y-axis, y, O, y dash. Then at x is equal to 0, y is equal to minus 4. Minus 4 will be 1, 2, 3, 4, somewhere here. And x 0 means this is my first point, and that is marked by A, and its coordinates are 0 and minus 4. Now second point B, at x is equal to 1, y is minus 1. x1 will be somewhere here. So 1, this is a point B, and that will be marked as 1 comma minus 1, because value of x is 1 and value of y at point B is minus 1, or abscissa is 1 and ordinate is minus 1. So this is 1 point. Then third point C is equal to 2 comma 2. So 2 is somewhere here, and 1 and 2 somewhere here is your point C. Its coordinates are 2 comma 2. Now when we join them, I hope you can see that we all get a straight line, something like this, that has been extended in both the directions. If you use the graph paper, you will get exactly the straight line. Now they say what is the value of y when x is equal to minus 1. X is minus 1 means somewhere here. It means it will be somewhere here at this point. 4, 5, 6 or maybe 7. It will be something like 7. Suppose say 4, 5, 6 and 7. It will be point minus 7 will be here. So its coordinates will be x is minus 1 comma minus 7. Let us say this coordinate is D. And how I calculated, when you will draw the graph, you will find that this point minus 1 is somewhere here. It will coincide, x is equal to minus 1, so minus 1 is this. It means it will be somewhere at this point. Because I am not using the graph paper, so I am not getting the accurate distances, but it will be somewhere here, that is minus 7. And how you can check out, if you put the value of x as minus 1 in this equation, so minus 3, it will be minus 3, and minus 4, that comes out to be minus 7. This is one way to justify. Because we don't have the graph paper, it means the diagram will be a little bit different. Now what will be the value of x when y is equal to 5? So 1, 2, 3, 4, 5. Somewhere here it will be the value of, it means 5, 5, 5, 4, 9, 3. It will be somewhere like this. It will be something like, let us say this is the point 3. So value of x will be 3 when y is equal to 5. So when you will use the graph paper, you will come to know this is the method that I am explaining, because I cannot use a graph on this. So now we move on to the next question. Now next question is question number 6 that I have taken, and that is also based on the graph, but I will try to solve it. Now they say, I'll read out the question. The graph of the linear equation in x and y. There is a linear equation that can be a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Now any equation can be ax plus by plus c is equal to 0. We have drawn the graph of this equation and this is coming a straight line. And they say that this straight line is passing from point 4, 0 and 0, 3. So first of all we will make the graph. Though all the numbers are positive, it means we need only the first quadrant. So I am rubbing out all this. This is point O, this is x dash, this is y dash, y and x. Now they say that the line or the graph passes from 4, 0, means x is 4, y is 0. So 1, 2, 3, 4, 5, 6, 7. Similarly 1, 2, 3, 4, 5, 6, 7. First point, let us say this is point A. Point A, and let us say that this is point B. Point A passes from 4, 0. So 1, 2, 3, 4 and 0 means it will lie on x-axis. This is point A which passes from 4, 0. Then point B is 0, 3 means x is 0, y is 3. 1, 0, 1, 2, 3. Somewhere here is your point B and this is 0, 3. It means we will join this line like this. Now they say find the value of k if the graph passes through k and 1.5. 1.5 will be somewhere here. 1.5 of y. 1 and 1.5 will be somewhere here. So it means if I draw perpendicular from this point, so this will be the point and the value of k will be something like this. It lies on 2. So you can say the coordinates of this point is 2, 1.5. So value of k, value of x, that will be k, is equal to 2 units. That is the value. So this finishes off with this exercise. Now we move on to the next topic, that is graphical solution of a pair of linear equations. Now next topic is graphical solution of pair of linear equations. Graphical solution of pair of linear equations. This we have already studied in our algebra part, because we know that there are two equations. One is a1x plus b1y plus c1 is equal to 0, and if other equation is a2x plus b2y plus c2 is equal to 0. If these are two linear equations in two variables given, then we used to solve the values of x and y by three different types of solutions. First was substitution method. Second was elimination method, and third was cross multiplication method. Now one more method is added to these three. The fourth one is graphical solution, but this we are using with the help of geometry. So this we are going to learn in this chapter. Now what we need to do when we are going to solve the solutions means in the algebra part. In algebra, we used to solve, or we used to calculate or find out the values of x and y by any of these methods. Same thing we are going to do in coordinate geometry also, or we are going to find the values of x and y in this chapter also of the same thing, means everything is same, but the method of working or method of calculating the values of x and y is very different. Here we used similar calculations, means addition, subtraction, multiplication, all that, but here we are going to draw the graphs and then we are going to solve them or find the values of x and y. Now you know that whenever we draw the graph of two equations, two linear equations in two variables, we always get a straight line. So there are three conditions: first, second and third. First condition is that if there are two lines, they may intersect each other at only one point. What is the first condition? That if we draw the graphs of these two equations, let us say that graph of this equation is line L1 and graph of this equation is line L2, represented by line L1 and line L2. Suppose I am making the graph of the first equation, and this is my line L1 and this is my line L2, the equation of the second graph. So we see that line L1 and line L2 we intersect each other at this point. So this point, whatever is the value of x and y means whatever is the value of abscissa and ordinate at this point P is the solution of the linear equations. Either we solve it by graphical method or substitution or elimination or cross multiplication method, we will always get the same value if the lines intersect each other at one and only one point. That is the condition, means they should meet at one and only one point. It is not possible that you draw a straight line and another straight line comes and again cuts it to one point. So it cannot be possible that there are 2 points, because two straight lines can intersect each other only in one point. It is not possible that they intersect each other at 2 or more points. So if this is the condition, then we say, means I am writing one and only one point. And only one point. This is the first condition. And then we say that the solution of these lines, we use a word, is consistent. We use a word consistent when two lines intersect each other at one and only one point. Then we say that the solution of these two equations is consistent, and we can say consistent and independent. Independent. These are the two words that you need to remember. That when two straight lines intersect each other at one and only one point, then we say that the solution of the equation is consistent and it is independent. Now second point, if they do not intersect each other at one point, they will be either parallel to each other. Parallel. So now I am drawing two lines parallel. Now these two lines are parallel, means they will intersect. If they are not going to intersect, then the second possibility is that they are supposed to be parallel to each other. And you know that parallel lines, they do not intersect them anywhere, even if you extend them till infinite. So it means that they do not have any common solution. In this they have one common solution, or you can also write in this one common solution. They have one common solution. But when the lines are parallel, since they don't intersect, so they will not have any common solution. So then we say that these points, second point is, we will get a graph of parallel lines. And when the lines are parallel, then we say that no common solution. The word we use is no common solution. When the lines are not intersecting themselves, there is no point common between those lines, then we say that no common solution. If there is no common solution, then we say that it is what we say? Then we say that the solution is inconsistent. Inconsistent. No common solution or no solution means that when the lines are parallel, then they are said to be inconsistent. No common solution and inconsistent. That is the second point. Or you can take third or first, whatever. Means these are the three different types of solutions. Now third point is that they have all the common solutions. All the common solutions means I draw a line and the other line is also overlapping this line. So it means all the points here which lie on both the lines are common. If the lines are common, then we say that they are consistent, means common solution. We will say in this it was one common solution, no common solution, and common solution. Common solution or all common solution. I am writing all in bracket. Means when two lines overlap each other like this. One line is this and the second line is this, and these lines are overlapping each other, means all the points on one line satisfy all the lines or all the points on other line. So then we say the solution, common solution, and we say overlapping lines. Overlapping lines. Lines overlap each other. And here we say intersecting lines. Intersecting lines. Intersecting lines, parallel lines, overlapping lines. And then we say the solution is consistent. Consistent means whenever you get even a single common solution, then you can see consistent. Here also many solutions are there, so again it is consistent. And if there is no solution, then inconsistent. You can memorize that. Then one more thing is there, and they are, here it was independent and here it is dependent. Dependent. So always remember that when we draw the graph of equation equation in two variable, and if there are two equations, when we draw the graph of two equations, the lines will be either intersecting or parallel or overlapping lines. When they are intersecting lines, the solution is consistent and independent. When we have overlapping lines, then the solution is common solution for all, consistent and dependent. And when there is parallel set of parallel lines, then we say no common solution or inconsistent. You need to remember this. Now the rest part is there in the next class. Now we will see, we will take up few questions. With the help of that, I will be explaining you how to solve the equations. Now I am starting with exercise 19.3. In this, first question is solve the following equation graphically. Second is solve the pair of equations graphically, plot at least 3 points. So first and two I am leaving. I am moving on to the third one. Using the same axis of coordinates and same units, solve graphically. So the general meaning of the question is that you have to solve these given linear equations with the help of the graph, or with the help of the graph you have to find the values of x and y. The language of the question may be different, but the basic concept is that in all the questions of this type you have to find the value of x and y with the help of graphical solution. So as we have discussed in the previous class, we always make the subject as y. So in first equation we will get y is equal to minus x, and from the second we will get 2y. 3x minus 10 upon 2 will be the value of y from the second equation. Now then what we do, we make the table, and that table should contain at least three different values. This is for first equation and this table is for second equation. Though I am writing it 1 and 2, but you all are supposed to write the equation. Or instead of 1 and 2, I can say x plus y is equal to 0. This is the table for x plus y is equal to 0, and this is for the second equation, that is 3x minus 2y is equal to 10. Now this is x and y. When we take the value of x as 0, y will be 0, so first value is 0, 0. When we take the value of x as 1, the value of y will be minus 1. When we take the value of x as minus 1, so minus 1 into minus will become plus, so plus 1. We got the three values for the first equation. Now in the second one it is 2, so 7 minus 10 minus 3, 7. So let us take x is equal to 0. In the first case, if I take x equal to 0, it will be minus 10 upon 2, that becomes minus 5. Now I will take 2. Let us take 2. X as 2. So 3 to the 6, 10 minus 6 is minus 4 upon 2 is minus 2. Now if I take the value as minus 2, so 16 minus 16 upon 2 is minus 8. We have got the values of our points. Now we will draw the graph. So this is my x dash x axis, this is my y dash y axis. First we will plot the points of first equation. At x0, y is also equal to 0. So this is my first point, I am marking as O. Second will be A, third will be B. 1 at x is equal to 1, y is minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I have marked all 10 points on all the 4 OX, OY, OX dash, OY dash. Now, x was 1, at x equal to 1, y is minus 1. At x equal to 1, y is minus 1, somewhere here is your point B. B is 1 comma minus 1. Sorry, A, this is point A, not B. This was written as A. B is minus 1, x is minus 1, y is 1, somewhere here is your point B. So when I join them, you can see we get a straight line, something like this. You can extend it in dotted in both the sides, so that it means that this is a line segment. This is my point B. B is mentioned by minus 1 comma 1. I am writing minus 1 comma 1 is your point B. Then let us say this is P, Q. This point P, point Q, point R. At x equal to 0, y is minus 5. At x equal to 0, y is 1, 2, 3, 4, 5. Somewhere here is your point P. And the coordinates of P are 0 and minus 5. At x equal to 2, y is equal to minus 2. X is equal to 2, y is somewhere here. At this is point Q. It is 2 comma minus 2. Then at x at point R, minus 2 is somewhere here. Y is minus 8. So 1, 2, 3, 4, 5, 6, 7, 8. It means somewhere here is your point R, and the coordinates of R is minus 2 and minus 8. Now when we join these 3 points in a straight sequence, it intersects somewhere at point 2 and minus 2. So the points, the value of this point will be somewhere between 2 and minus 2. So the value of x is 2 and the value of y is minus 2. So we are getting the value of x as 2 and minus 2. Means this may be correct. I think it will be correct, but because my measurements are not very accurate, but it will come something like 2 and minus 2. So with the help of these equations, we have calculated that x is value 2 and y is having minus 2 value. So this is the solution, or this is the answer. If you want to cross check, you can just solve these two equations. Let's say x plus y is equal to 0 and 3x minus 2y is equal to 10. Let's solve this equation by elimination method. So what I am going to do, I am multiply the first equation by 2. So this will become as 2x plus 2y is equal to 0, and second equation be like this only, 3x minus 2y is equal to 0. When we add these equations, they cancel. So is equal to 10. Sorry, it is 10, not 0, 10. So 5x is equal to 10 implies that x is equal to 10 upon 5, that is 2. So we are getting x as 2. It means our calculation or our graph is alright. Now you can put the value of x as 2 in any of the equation. If you put it here, means x plus y is equal to 2 is equal to 0 was the equation. We substitute the value of x as 2 in the equation. So 2 is equal to 2 plus y is equal to 0 implies that y is equal to minus 2. Value of y is also correct. So you can see either you solve it by algebra or you solve it by geometry. In both the cases you can see that the values are coming the same. Now second thing is, what type of lines are there? These are consistent, and they are only one solution, and so they are known as also independent, I think. So these are known as independent. And what type of solution will be? Consistent, only one solution, and independent. So I have taken up one question in this exercise. Maybe in the coming class we will be discussing 2-3 questions of this type, and then we'll move to a bit more complex questions in which you have to find out the area or you have to find the vertices and so on. So now I'm ending with my class. So till then, stay blessed and keep on studying, and also put a like and dislike if you feel like that. Thank you, all of you.